In this video, we're going to trace through the call stack trace for the binary search algorithm. I figured there's probably going to be enough people that would want to see this that I'll just go ahead and film it. If you have no curiosity about this, or you feel like you got it, then you can skip this video. So let's trace through it for the first call that happens in the main program. We call recursive binary search. So that's going to be our first call that gets added to the call stack trace. Remember, that'll fall all the way to the bottom because it's the first one. And it's getting called with the array. I'm not going to bother writing out the array because it stays the same at each time. I'm just going to include an A there to signify it's the same array. The value of first that gets passed in initially is 0, and then the length of the array gets passed in. This array has length 5. There's 5 items in it. And then the key value that we're looking for is 3. So those are the arguments that are being passed in to this particular call to the recursive binary search. And I'm just going to abbreviate recursive binary search RBS. So after we do that, it's going to make our recursive binary search call. It'll come down here into the method, and that's where our debugger will pick up. It's going to set the list equal to the values in the array. And again, those are going to be the same for all the calls. And then it's going to set first equal to the second argument, which is 0. And then last, that'll get set equal to the third argument, which is 5. And then the key is going to be the last argument, 3. And again, that's where our debugger is going to pick up. And you can see those same values are indicated there in the debugger window. Awesome. So now we can start stepping through to see what happens. So the first thing it's going to do is calculate middle, and it notes that first is 0, last is 5. So 0 plus 5, that's 5, divided by 2, that's 2.5. Remember, Java truncates when it does the integer division here, so it's going to store the value 2 as middle. And you can see that down in the debugger window, it's tracing through that value. So we'll track that in our own code. Middle is 2. Then we check to see if first is less than or equal to last. Yes, 0 is less than or equal to 5. So we're going to go through the checks to see if we found the key. So it's going to look to see is the key, which is 3, equal to the value in the list at position middle. So that's the value at position 2. That's the 5. It's comparing 3 and 5. And of course, those are not equal. So it's going to move to the if else. So now it's checking to see is the key less than the value at position 2. So is 3 less than 5? That's true. So it's going to return the call to recursive binary search, and it's going to, sorry, I jumped ahead too fast. It's going to return, and then it's calling recursive binary search, and it's using the values, the array, and then first, which is 0. And then middle minus 1, so middle minus 1 would be 1. And then key, which is 3. And so then it's making that recursive binary search call. I'm going to add that to my call stack trace. A, 0, 1, 3. So it's going to know that the list is the same 1, 3, 5, 7, 9, and that first is equal to 0 because that's the second argument there, and then last is equal to 1 because that's the third argument, and the key that we're looking for is 3. And so it's calculating a new value for middle. Sorry, I skipped over that already. I went too fast. So it's calculating the middle. That's going to be first plus last, 0 plus 1. Wait, maybe I didn't click it yet. There you go. All right, so now it's calculating the middle. Now I'm in the right spot. I'm synced up with the debugger. So it's calculating the new value for middle, where first is 0, last is 1. So 0 plus 1 is 1, divided by 2 is a half. But it's going to store 0, just the integer part of that, as the result. So middle is 0, and again, it'll show you that in the debugger. It's going to check to see if first is less than last. It is. So we're going to make our comparisons to the key. First comparison is, does the key value 3 equal the list at position 0? That's the 1. So no, they're not equal. So we're going to move to the else if. We're going to check to see, is 3 less than the value at position 0? And that's a no. So we're going to move to the last if. That's going to check to see if the key is bigger, which it is. So we're going to make a call to recursive binary search using the values, the list, middle plus 1, middle is 0, so middle plus 1 is 1, last, which is 1, and the key, which is 3. So it will show us that down here. I have to like scroll to see all that, but it'll show us the right value for middle and last and key. So now we're calling recursive binary search again. We're calling it with the array 1, 1, 3 as our argument values. So that means the list is the array, which is 1, 3, 5, 7, 9. The value for first is the second argument, that's the 1. The value for last is the third argument, that's 1. And the value for the key is the fourth argument, that's 3. All right. So now we're going to be calculating a new value for middle. Do that by adding together first plus last. So that's 2. And then dividing by 2, so that'll be a 1. And then we're going to check to see if first is bigger than or equal to last. It is, it's equal, so that's cool. We're going to compare the key to the middle value. So we're checking to see, is the key 3 equal to the value in the list at position 1, which is 3. So in that case, it is. We're going to return middle, which is equal to the 1. So remember, when you get to the return, that means this particular record is going to be removed from the call stack, and then the value that gets returned is going to be replacing that previous method call down here. So we're returning the value 1 here. That's being returned right here where we had previously called that method recursively. So it's coming down here to the return statement. Now it knows that the return value here is 1. And so we're going to be able to execute this return statement as well. The value that we're returning is 1. So where's that going to get returned? It's going to replace the previous method call right here, which was when we were in this particular line of code. And then the return value here, it's returning 1. Where is it returning that to? It's returning it to the original call from the main method. So it is going to return right here as the value result. And you can see that the result value gets updated as soon as it executes that line. Now it knows that the result is 1. It's going to be able to print that information to the screen. If we look at the console, it's going to have displayed that return value. If you feel like you need more practice, you can go ahead and do the same thing with the next call to the method, the one where we call it using the key value 2. It'll work just the same way, but it will eventually get to the point where first is not less than or equal to last, and it'll do the return of that -1 value at the end.